This program is designed to introduce you to the 757 radio navigation systems by describing the function and location of the major components within each system. The 757 radio navigation systems consist of the weather radar system, the ADF system, the Very High Frequency Omni Range or VOR system, the marker beacon system, the instrument landing system or ILS, the distance measuring equipment or DME system, the radio altimeter system, and the air traffic control system. The weather radar system provides the pilots with visual indications of weather conditions and is also used for ground mapping. The weather radar antenna is located in the nose radome. It is a flat plate type antenna that sweeps across the front of the airplane between 90 degrees left and 90 degrees right. Tilt angles from 15 degrees up to 15 degrees down can be manually selected from the weather radar control panel. Antenna stabilization is provided from the radar transceiver. The transceiver is located in the forward equipment bay. The front panel has a momentary self-test switch and 7 red LED fault indicators. The transceiver operates in the X band on a frequency of 9,345 megahertz. It has an output of 125 watts peak with a maximum range of 320 nautical miles. It processes the radar information and transmits the computed data to the display units. Warning: avoid prolonged exposure to weather radar radiation. It can cause injury to personnel and damage ground equipment. Refer to the Boeing Maintenance Manual for specific information. The weather radar control panel is located on the aft electronic panel, P8, in the flight compartment. Controls on the panel are the gain control, mode select switch, and the tilt control. When the mode select switch is in the map mode, the gain can be set automatically by the auto mode or manually by the control knob. When the select switch is in the weather mode, gain is automatically set. The weather radar system is activated from either EFIS control panel. Pressing the WXR switch on the control panel will activate the weather radar display on the corresponding electronic horizontal situation indicator or EHSI display. Weather radar displays are color-coded. Red indicates areas of high precipitation, yellow areas of medium precipitation, and green areas of low precipitation. Weather radar information can be displayed on the EHSI in the expanded VOR mode, in the expanded ILS mode, and in the map mode. Range for the weather radar displays on the EHSI is selected on the corresponding EFIS control panel. Brightness is adjusted by the inner brightness control knob on the control panel. An optional dedicated weather radar indicator may be installed in electronics panel P9. This concludes the module on weather radar operation and component location. The Automatic Direction Finder System, or ADF, is used to determine the relative bearing to a selected ground station with respect to the airplane's center line. ADF signals from the ground stations are received by the ADF antenna. The antenna is located at the top of the fuselage. It consists of a non-directional sense element, and 2 perpendicular mounted loop antennas for directional reception. The ADF receiver is located on rack E6-1 in the aft equipment center. The front panel contains LED status indicators and a momentary self-test switch. The ADF signal from the antenna is processed by the receiver, where the audio identifier is detected and the bearing is computed. Tuning of the receiver is from the ADF control panel. The control panel is located in the flight compartment on the aft electronic panel P8. It contains a frequency select knob, a frequency display, and a mode select switch. With the mode select switch in ADF, the audio identifier is transmitted to the flight interphone system and can be heard when ADF is selected on the respective audio select panel. And the computed bearing is displayed on both radio distance magnetic indicators, or RDMIs. In a single system, only the left bearing pointer displays the ADF bearing. In a dual system, each pointer reflects its respective ADF system bearing. With the mode select switch in the antenna mode, only the audio identifier is sent to the flight interphone system, and a flag will appear on the RDMIs indicating no computed data. This concludes the module on the automatic direction finder system operation and component location. The Very High Frequency Omni Range, or VOR system, provides navigation information by computing the bearing relative to a ground transmitter referenced to magnetic north. The VOR signal is received by the dual VOR antenna located at the top of the vertical stabilizer fin. The signal is sent to the left and right VOR receivers located on shelf E6-1 in the aft equipment center. Each receiver front panel contains LED status indicators and a momentary self-test switch. VOR bearing information is calculated by the receivers, and the data is sent to the RDMIs, the EFIS symbol generators, and the flight management computers. The receivers are tuned to the frequencies selected at the VOR control panels located on the center glare shield panel P55. Each panel contains an inner and outer VOR frequency select knob, VOR frequency display window, tuning mode switch and annunciator, course select knob, and a course display window. VOR bearing information is displayed on the RDMIs. The EFIS symbol generators compute VOR deviation and to-from information for display on the electronic horizontal situation indicators, EHSIs. On either RDMI, place the right or left VOR ADF selector in the VOR mode to cause the respective bearing pointer to indicate the VOR bearing. Bearing information is transmitted directly to the RDMIs from the VOR receivers. When flying a manually selected course to a VOR station, the frequency of the station and course are selected on the VOR control panel. The selected course is displayed in the Course Select window and on the EHSI. The EHSI is controlled from the Electronic Flight Instrument System, or EFIS, control panel. With the mode select switch in the full VOR mode, the EHSI will display the VOR course over the full compass rose. Also, VOR deviation, source, and to-from information is displayed. This information is computed within the EFIS symbol generators. Place placing the EFIS select switch in the expanded VOR mode will display the same information over a partial compass rose. When the full or expanded VOR or ILS mode is selected on the EFIS control panel, the VOR tuning mode switch annunciator is in the manual mode and the VOR frequency is manually selected. When the EFIS mode select switch is placed in the map or plan mode, the computed bearing is transmitted to the flight management computers, which use this information for secondary navigational computations. In such an event, the VOR tuning mode switch annunciator will change to the auto-tune mode, and the VOR frequency will be selected by the left flight management computer, FMC. The automatically tuned frequency is displayed in the frequency display window. Automatic tuning may be overridden by pressing the VOR tuning mode switch annunciator. The VOR frequency can now be manually selected. The selected VOR ground station can be identified through the flight interphone system by selecting the appropriate left or right VOR select switch on the flight interphone audio select panel. This concludes the module on the very high frequency omni-range system operation and component location. The Barker beacon system receives signals that are characteristic of a particular ground beacon. It provides an audio and light indication to the flight crew when the airplane passes over a particular ground station. Signals are received by the marker beacon antenna located on the airplane bottom center line at station 613. The signals are sent to the marker beacon module located within the left VOR receiver in the aft equipment center on shelf E6-1. In the flight compartment, marker beacon indication is by 3 lights on the pilot's P1 and P3 panels. Audio identification can be made through the flight interphone system. As the airplane flies over the outer marker beacon, the blue outer light flashes in synchronization with the dashes of the 400 Hz audio identifier. As the airplane flies over the middle marker beacon, the amber middle light flashes in synchronization with the dashes and dots of the 1300 Hz audio identifier. As the airplane flies over an inner marker beacon, or an airways marker beacon, the white inner light flashes in synchronization with the dots of the 3000 Hz inner marker beacon identifier. Or the Morse-coded 3000 Hz identifier of the airways marker. This concludes the module on the marker beacon system operation and component location. The instrument landing system provides information to the flight crew on the airplane's position with respect to the localizer center line and glide slope during landing. The system has 2 dual localizer antennas and 2 dual glide slope antennas located in the nose radome. The left half of the upper localizer antenna is used by the center system. The right half is not used. The left half of the lower localizer antenna is used by the left system, the right half by the right system. The assignment of the glide slope antennas is identical. The left half of the upper glide slope antenna is used by the center system. The right half is not used. The left half of the lower glide slope antenna is used by the left system, the right half by the right system. The ILS receivers are located on shelves 1, 2, and 3 of the E2 rack in the main equipment center. Each receiver receives signals from dedicated localizer and glide slope antennas. The receivers compute the localizer and glide slope deviation, extract the audio identifier signal from the localizer signal, and transmit outputs to the displaying and using systems. The front panel includes LED status indicators and a momentary self-test switch. Output of the three ILS receivers is sent to their respective flight control computers and EFIS symbol generators for display on their respective EADIs and EHSIs. The output of the left and right ILS receivers is also sent to the left and right flight management computers. The output of the left ILS receiver is also sent to the ground proximity warning computer. Output of the center ILS receiver is also sent to the standby attitude ILS indicator. Audio identifiers from all three receivers are sent to the flight interphone system. The ILS control panel is located on the center control stand's aft electronics panel, P8, in the flight compartment. Controls on the ILS control panel are the ILS frequency selector and display window, the ILS front course selector and display window, and a momentary self-test switch for system self-tests. When making an ILS approach to a runway, glide slope deviation and localizer deviation are displayed on the EADIs. And with ILS selected on the EFIS control panels, glide slope and localizer deviation displays are shown on the EHSIs along with the ILS frequency and mode. Localizer and glide slope deviations and ILS frequency and mode are also displayed on the EHSI when the full ILS mode is selected on the EFIS control panel. The detected Morse-coded audio identifier is transmitted to the flight interphone system and can be heard when left, center, or right ILS is selected on the audio selector panel. This concludes the module on the instrument landing system operation and component location. The distance measuring equipment measures the slant distance to a DME station. This distance is computed from the time interval that a signal needs to make the round trip to the ground station and return. The DME antennas are located on the lower fuselage. The left DME antenna is at station 630, and the right DME antenna is at station 690. The same antennas are used for transmission and reception. The left and right DME interrogators are located in the main equipment center on rack E3-3 and E3-2. The interrogators generate the signals which are transmitted by the antenna and compute the distance from the received returns. The front panel contains LED status indicators and a momentary self-test switch. Flight compartment displays for the left and right DME are on both RDMIs. Control for the DME displays on the EHSIs is from the EFIS control panels. The left EFIS control panel controls the DME display on the left EHSI, and the right panel controls the right EHSI. The left DME distance is displayed in the left windows of both RDMIs, and the right DME distance in the right windows. With full or expanded ILS mode selected on the EFIS control panels, the DME display on the respective RDMI is preceded by the letter L. When either of the EFIS control mode select switches is placed in the full or expanded BOR mode or ILS mode, the DME distance is displayed on the respective EHSI. A Morse code DME identifier is transmitted over the flight interphone when left or right VOR is selected on the audio select panel. When the DME is paired with an ILS station, the DME is heard when the ILS is selected on an audio select panel. One DME code at 1350 Hz is transmitted for every 3 ILS identifiers at 1020 Hz. This completes the module on DME. The radio altimeter system provides accurate terrain clearance altitude information at low altitudes, primarily during approach, landing, and takeoff phases of flight. The radio altimeter transmit antennas are located on the bottom of the fuselage at station 570, and the receive antennas at 610. They are the left, center, and right transmitter antennas, and the left, center, and right receive antennas. The same type of antenna is used for transmission and reception. The 3 radio altimeter receiver transmitter, or RT units, are located on the E5 rack in the mid-equipment center. These units generate and transmit a radio signal, receive the reflected signal, and compute the radio altitude. The front panel contains LED status annunciators and a momentary self-test switch. Output data from the RT units is sent to the EFIS system for display on the EADI in numerical format. Below 200 feet, with a valid localizer, an optional rising runway is available. Output data is also sent to the Autopilot Flight Director system, ICAS, Ground Proximity System, and the Warning System. The radio altimeter system controls are located on the EFIS control panel P10 on the quadrant stand. Controls on the panel are the decision height set knob and readout display, decision height reset switch, and EADI display brightness control. The selected decision height is displayed on the control panel, and in the upper right corner of the EADI above the displayed radio altitude. When the airplane descends through the selected decision height, the decision height display changes to a yellow DH, and the radio altitude display changes to yellow. The yellow DH blinks for 3 seconds. The decision height alert is reset by pressing the reset switch on the EFIS control panel or automatically at touchdown. The alert is also reset if the airplane climbs to an altitude 75 feet above the selected decision height. At reset, the radio altitude display changes back to white and the selected decision height to green. This completes the module for the radio altimeter. The Airborne Air Traffic Control, or ATC system, enables an ATC ground station to identify an airplane, its altitude and airspeed, and to track the airplane on radar. This is accomplished by the ground station transmitting an interrogation for airplane identification and baro altitude. Airspeed is computed by the ground station using tracking information. The ATC system consists of the left and right antennas, located on the forward center line on the bottom of the fuselage, the left and right transponders on the E3 rack in the main equipment center, and a dual ATC control panel located on the aft electronics panel P8. The ATC control panel contains controls for code selection, a code display window, a selector for the left or right transponder, an altitude reporting on-off switch, and a special position identification switch which is used to respond to a voice request from a ground ATC station. When an interrogation signal is received by the transponder, it decodes the signal and generates a reply based upon the code set on the ATC control panel or the baro altitude received from the air data system. The transponder front panel contains LED status annunciators and a momentary contact self-test switch. This concludes the module on the ATC equipment on the airplane and completes the presentation on the 757 radio navigation system. You have seen the function and major components of the weather radar system, the ADF system, the VOR system, the marker beacon system, the ILS system, the DME system, the radio altimeter system, and the ATC system.